Welcome back to Advent of Code 2024, day 6. So yesterday we had some topological sorting. That was an interesting problem. And alright, what's today going to be about? Day 6, God Gallivant. The historians use their fancy device again. This is the device from the story. So it's like a time-traveling device. To whisk you all the way to the North Pole prototype suit manufacturing lab in the year 1518. This was 2018. Oh yeah, I remember this. It turns out that having direct access to history is very convenient for a group of historians. I suppose it would be. You'll basically shatter everything they've theorized, because I bet most of history is like 90% wrong. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. Start by making a map of the situation. For example, the map shows the current position of the guard with a carré to indicate the guard is currently facing up. Any obstructions are hash. Lab guards in 1518 follow a very strict patrol protocol, which involves repeatedly following these steps. If there's something directly in front of you, turn right 90 degrees, otherwise take a step forward. Okay. Following the above protocol, the guard moves up several times until she reaches an obstacle. Because there is now an obstacle in front of the car. Yeah. Okay, I get it. By predicting the guard's route, you can determine which specific positions in the lab will be in the patrol path. Including the guard's starting position, the positions visited by the guard before leaving the area are marked with an X. Okay. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? Okay. Straightforward. It's really just a while loop. We're gonna have like multiple guards for the next part. Oops. And there's also a carry somewhere here. There, okay. So, we want to create a map. Just call it grid equals like that. with open reminder grid dot append line dot strip. Check if. Okay, let's check this first. Row equals line dot strip. Oh, we'll need to keep track of where the carry is, so we can say for I line in enumerate f.read line. So we want to know the row that it's in and also the column. So row equals line dot strip. If carry in row start equals, so it's going to be I row dot find carry. Is it find or index? I think they both do a similar thing. So that's going to be the starting coordinates. Start I row dot find carry. We also need to replace that carry because we don't actually want it there. That should just be an empty space. And then we want to just append that row to the grid. So we should get a start position out of this. Print start 6795. Okay. So should we create a pos class for this? I don't think it's overkill. It's probably worth doing. Alright, so what I usually do is... Oh man, I should just copy some pos code from my coding game stuff. Let's see if I can... just find my pos code. It's not going to be that complicated. But I'll just simplify this. So, past events. Oh, there's an upcoming challenge in 13 days. So that'll be another stream I'll do. October 3rd. What was this? Okay. This one I didn't define edition. Hang on, let's go back. What was the previous one? Summer challenge? That had nothing to do with pos. Alright, let me go back one more. In the time I've been searching for this, I probably could have just typed up a pos class. It's not that hard. Alright, here we go. Alright, most of these methods we don't actually need. Okay, so we're importing data class. All right. So we define addition, subtraction. We don't even really need it subtraction. We do want equality and hash. Do we need subtraction? Oh. Just adding a delta each time. Floor division. Not gonna need that. Yeah, we don't need any of these things. There we go. Yeah. So basically, what I've done is we're creating a vector xy. We define how to add two posits together. We define how to check if two are equal, and we check how to hash because we're going to have a set storing all the posits that are visited. That needs to be a set to avoid duplicates. So okay. So position equals pos start 0 start 1. These are actually, we just rename these i's and j's. We're thinking in terms of rows and columns, not Cartesian coordinates where y would go up. We go down because that matches the way that matrices, lists and matrices, programming matrices work. Okay. So direction is going to be -1, 0. Up. That's one row up. No columns across. Okay. So visited equals, it's going to be a set, so we can actually populate it with the current position. All right. Okay. Let's just say n equals length of grid. M equals length of grid. First row. It's got some values there. So while we're inbounds, let's say define is inbounds of a pos. Return, so we want the 0 to be less than or equal to pos.i is less than n, and 0 is less than or equal to pos.j is less than n. Okay. So, while is inbounds pos, say like p, avoid using pos over and over again. All right, while is inbounds pos. Okay, so while the guard is inbounds, we should, hello Smab UK, maybe maybe we should populate visited and as this first operation. So visited dot add. So we add this position that the guard is standing in. Now we have to follow this this set of steps. So what's this saying? Overrides method. Yeah, we want to do that. Yeah, I don't care about blank lines. All right, so let me read this again. Okay. So we keep going. Okay, so we say, okay, we now try to take a step. Destination equals pos plus direction. So that's where he's facing. If we're going to allow him to walk off the grid, so the only case we don't, so let's say if is inbounds dest. So if it's inbounds and grid pos.i pos.j equals hash, that means it's an obstacle, so instead turn right. So direction equals pos dot what's the, I gotta Google this, I can't think this out of my head. The matrix for rotating clockwise by 90 degrees is okay, they're not giving me what I want. Google. Don't make me resort to ChatGPT. No, I'm not going to do that. I mean, it would be allowed for this kind of query, but still, I'm not going to do that. Yeah, it's y x minus x, y minus x. I could have easily reasoned that out in my head, but I didn't. So it's so we just swap the things. Pos.j minus pos.i. Is that right? Let's see. We start going up. So if I rotate clockwise, we're going to take, it's going to become 0, 1. So that's 1j. Yeah, that's correct. Should we make this into a method? Pos, define, rotate clockwise, C-wise, rotate, and we'll call it rotate right. like that. Position equals position dot rotates right. Pause equals pause dot rotate right. Okay. Else we just go forward. Oh. No. It's direction that changes, not pause. Else pause plus equal direction. Okay, I think that's the full set. And as soon as we're out of bounds, we won't add that. So should just be length of visited. Visited is... Oh, that's a set. Oz has no attribute X. Alright. And it's in an infinite loop. That is wrong there. That should be dest, not pos. We're saying if the destination is a we can just say here pos equals dest. There we go. 5269. It's quite big. Well, it was a big grid. Correct. While the historians begin working around the guards' patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Oh, I remember this one. This was 2018, but I did it recently-ish, in the past year or two. Returning after what seems like only a few seconds to the historians, they explain that the guards' patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. Ooh, loop detection. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard's starting position. The guard is there right now and with notice. Okay. How many different positions? Okay, well, I suppose to begin with, we can restrict to the actual positions we know that the god will ever come across. Except for the current position. Not that... I mean, okay, so... This... So what... Maybe what we wanted to do is tie this up as a method, which will either... Which will return two values. One, whether or not he leaves the map. So it has to do loop detection. And two... Loop detection's easy. That's what the visited set is doing, but the visited set would have to take direction into account as well. We could have a separate map. State set. If we ever return to the same state as before, then that's a loop. So define. So it's going to detect whether the god leaves the map, and also as two values, it returns a set of all visited nodes as well. So define or do it the other way around, then we can call it state. That's the word I was looking for earlier. I ended up with cache. All right, yeah. Define. Okay. Get guard path. It's not quite getting his path. It's getting his span. The path would indicate some sort of direction or time. We'll call it get guard span. Maybe it's a bit weird. I don't know. Get guard span. Given given a new obstacle, which doesn't necessarily need to be provided. Biggest comment I've written this year, this year's Advent of Code. Option to add additional obstacle position. Okay, so this is gonna do this basically. So this. Visited set, and let's say states is a set as well. We can okay, we're not going to populate states at the beginning, so we'll just say states, we can initialize with pos direction. Oh yeah, pos direction need to be defined as well. That's visited states. We populate visited at the beginning of each step because we're only interested in cells on the grid. State space will be anything, even if it's off the grid, and it also includes direction. Okay, so we do this as normal. We just want to say here. So either it's a hash or the destination is the optional obstacle. So if it's none, that won't matter. New obstacle. So we're checking for the new obstacle. So that is as normal. If I wrote a C# to Python translator, I think I would end up with your code for mine already. Yeah, it seems that there's a fairly clear path to follow here in terms of coding it. Because it's a simulation rather than an algorithm. So after we move, so here the state has changed, whether the direction changed or the pos changed. So we want to say new state equals pos direction. If new state in states, that means it's a loop. So we just return fail. So success means we leave the map, so false, and we can return the visited set. We don't even need that for this, do we? We just want to count how many. We'll do it anyway to maintain the description here. So states.add new state. So as soon as we leave the map, we get to this point here. Return true visited. So this should do the same thing now. Part 1, print, get guard span. Get guard span 1. That just gets the visited set. 5269. None type because it's only comparing against equality. Maybe this isn't. We should also say return other. What do you say? Is Oz? Is that right? We're saying the thing we're comparing with is a type of pause. 5853. What changed here? So this shouldn't have changed anything. Let's see what we actually get here. God span. What was the Boolean? True. Yeah. You wouldn't think... Okay, maybe the obstacle thing is somehow messing it up. So let's check this again. 4853. We should be getting... what was it? 5269? How did I get so many more? Alright, let's check if this Boolean here is somehow breaking it. So let's take that out. Five eight five three still. What? So that addition didn't. I mean, this shouldn't have changed anything. If we just comment this out, it should just be like the original code. 5853. If I take this out... Oh god, what have I done? It must be something simple then, just like a wrong variable name or... Visited. I would think that is now just my original code. True. Okay. Somehow we are... This is why I use Git. Yeah, that would be good. I'm not sure where to begin now. 5853, so we somehow added another 600 and something. Maybe we're only calling this once. Spam. Return. Oh man. Doesn't make any sense. So we're getting new things in Visited that weren't there before. So maybe is inbounds. We shouldn't. No, we're never changing grid. Grid is fixed. I should be able to solve this just from this function here, because I could have just written this to begin with for part 1, so... should I just pull the basic example then? States. Test. Pause. Direction. Like the most obvious thing will be that I've somehow used a variable from outside grid. Just.I. We're using ij, that's correct. This return comes... I don't know. Let's try the simple example again. $45. We should be getting 41. Maybe we're adding the obstacles in somehow. If let me just change this again. So this is how it originally was. Should have been. Grid, dest.ida, return right. Else, we step forward. 45, fuck's sake. Okay, let's print. Gift card span. Let's just print the new... Could Control Z all the way back to, it's not like we really added much. Or I could just pull up my video and look back at the video to see what my code looked like. Let's try to debug it anyway. Hopefully this doesn't take too long. Let's just, oops, no, don't change that. Let's say, for v equals get guard span 1, so that's the visited set. For p and v, grid p, so for that row, dot. Oh, but it's a string, so we need to equals so it's going to be like this up to, if it was a list I could have changed things, or we could still make it a list. Plus, let's say, just x plus like that. And now for row in grid, print row. Okay, what does this look like? Object system subscribe. What? Grid. Oh, yeah, should be p.I, p.j, p.I, p.j. Oh. p.I. All right, what's going on here? Does this look like? What? So this is what it should look like. Let me just paste it up here. Well, that's identical. So how many X's are there? Am I not counting the size of the visited set correctly? What did I say? Length of visited? The print length of the print take this out. $45. But that looks correct to me. 41 distinct positions on your map. Let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 41. There's 41. Why is it saying 45? What the... V is a set, right? Oh no. It's because of what I did with the equality. Why would that not be right? Return other is pos, so it's not... This is always giving false. Okay, I should have looked this up. How do you check... Python check something is member of class. Is instance, not is. Oh my god, yeah. Is not correct. Is checking if it's... the class pos, whatever that even means, is instance. Do you do it like that? Oh my god. I wasn't sure about what I was doing there. I should have looked it up. No. How do you do it? Is instance. Is instance, so you need to put... pause. All this because of a stupid none. Wait, I don't understand how to use this. Is instance bracket... okay. That? Oh, comma. Return other is instance. Oops! Yeah, take the other out. Oh my god. $41, there we go. Wow. Yeah, is was completely wrong. I was thinking of is instance. Because I forgot I changed that. So I was just worried about what I changed here. Yeah, that's why I should have used Git, really. Okay. We're back on track, I guess. So I'm gonna say all this because I refused to just do an extra none check here. Or dest equals new obstacle. Still 41. Good. Just get rid of all this. Alright. Visited equals get guard span. Print length. Visited. Okay, we've solved part 1 again. Okay. Part 2. Yeah, I'm sure we have. Alright, so... and I'll learn that lesson about is instance. because, I mean, normally I would have just done a none check here, but I was too lazy to just write one more clause in that. But that is the correct way, really, to do it. We do want to check that something's the right class. Otherwise, this will throw up errors if we try to compare it with something that's a different class. Okay, so part 2, we want we can use this visited set. So let's say obstacle candidates equals, it's going to be visited minus the starting position, because we're not allowed to place an obstacle at the starting position. But any other visited spot is a candidate, because any non-visited spot, there's no point putting an obstacle there because we never tried to go there ever. Okay. Or obstacle in obstacle candidates if, so basically we want to run this again, get guard span with this obstacle, we could just get the Boolean variable. If it's true, wait, what were we trying to do again? I don't remember what the point was of these obstacles. Oh, we want to get him stuck in a loop. Okay. If not, so really success should have been, okay, it doesn't matter. Indicate success of leaving map. Oh, well, okay, we'll just make this match what we actually want. So second value returns bool to indicate success of looping guard, and change this all around. So say return true, return false. Okay, so if get guard span obstacle 0, are we just counting how many times? How many different positions? Okay. Six? Oh, well, yeah, that's the test example. Okay, 6 is correct for the test example. Okay, it could take a while because we're, as long as we don't actually run this infinite loop, we shouldn't. As soon as we enter it again. So yeah, restricting to the visited set helps quite a bit. I hope it's not getting stuck in an infinite loop though. 1957? Okay, took a few seconds. Correct. Alright. Could have gone smoothly if I hadn't done that stupid thing with the is instance. But yeah, I think that's a good problem overall. It's one of the simulation problems, so there's not really different ways of doing it. Algorithmically speaking, you're really just simulating it step by step. of course, the loop detection is a key step that some people might not do properly. There are a lot of classic interview problems revolving around loop detection, like detecting a loop in a linked list is one of the most popular interview questions ever. Mine takes around 2 seconds. Yeah, so optimization-wise, I don't know what I would really do. Suppose if you... I don't see any real algorithmic shortcuts we can take here. It seems like this is at least the way I've written the code, this is as much work as I needed to do. Like, restricting to the visited set was a good optimization. We certainly can't restrict any further, can we? Oh, okay. Yeah, we can speed this up by like caching past states if we know what those are going to lead to, but that's a bit tricky because the new obstacle we add can be hit from multiple angles. You can definitely reuse knowledge of past events. It's just this new obstacle thing is a bit... You have to account for it, so I'm not sure exactly what you would do. You can... Same thought process I had and also rejected. Yeah, it's not... Maybe it's not as easy as it seemed. Because it's always possible to have... Even if you've hit this obstacle and you know that state is covered, it could still be possible to hit it from the other 3 sides, so you don't really know what will happen down the line. An infinite loop state may not always be an infinite loop state, depending on where you place the... Yeah, it's not something I particularly want to try. Okay. What day was this? 6. "10 seconds for first star." Yeah, no, I have trouble believing that. Yeah, pretty sure you can't extract the quirks of the obstacle and stuff like that in 10 seconds. Well, there's becoming less and less value of me even looking at this leaderboard. All right, we'll go to the private leaderboards. Mara hasn't started yet. I think my solution is the same as yours. Oh yeah, I can have a look at that. Um... Mm-hmm. Stuck in a loop. Yeah. Yep. Pretty good. Alright then. Maybe I'll have time to actually do some Satisfactory today. And I'll be interested to see Captain Coda do this one in a couple of hours. Cool. Alright. That's it then. I'll go and get started on uploading this to YouTube. So I won't bother raiding anyone today. Alright, thank you for watching, and see you tomorrow, probably around the same time for day 7. Bye-bye.